Good morning, everyone. This is Varshit Dandu, and I'm with my partner Shashikant Reddy Manuru. We have done a project on machine learning, which is traffic sign recognition and accuracy using convolutional neural network. So, coming to this project, traffic signs provide valuable information about roads. Road traffic signs are the plays vital roles in the safe and smooth driving. So when the when the vehicle need to be autonomous, there should be a proper detection and classification of those images. So road sign recognition is acquired by camera. It actually uses the computer vision, and lately artificial intelligence has played a great role in detecting and classifying these images. So objective of this system is detection and classifying the road sign. Detection of signboard is a much complex task when compared when the vehicle will be moving, as there will be a noisy data, as the images won't be clear, which we can technically call them as a noisy data. Coming to the problem statement, the detection and classification of traffic signs using convolution neural network with additional operations for the overfitting issues are batch normalization, dropout, and data augmentation with a higher accuracy.
Coming to the central questions, uh, traffic recognition is having with the autonomous vehicles, whether the autonomous vehicles can able to detect the traffic signs whether due to the weather conditions or not. And suppose if the weather conditions changes for the season, like lightning and to the due to the dark, in that bad weather conditions, whether the detection of signs is able to do it or not. And the next question is about the accuracy of the traffic sign detection. How much accuracy we are able to get with the previous methods of, I mean, previous using previous methods and recent, I mean, using machine learning techniques. And we used convolutional neural network. Is it fast enough to detect the change in traffic chains? And that we got answer kind of like, because convolutional neural network is a proved method for classification of image pattern recognition problems. So when it comes to the motivation, recognition of traffic sign is a challenging problem for many years, and it is an important task for intelligent or autonomous vehicles. And traffic sign recognition is a great significance for improving road traffic safety. Many techniques or robots are able to detect and recognize the road signs with high accuracy, but none of these can be totally immune to the problems faced by the auto automatic road sign recognition system. And in this field, I mean, still it is necessary and require more attention while while using autonomous vehicles. We can't fully depend on the vehicles. Still we can, right now the present trend is to just classify or alert the driver about the signs, so that he can be cautious about the road accidents and everything.
Uh, Coming to the related works, there have been many techniques used earlier in the in machine learning techniques. There are six of them used, which we have noticed are template matching, decision tree, k nearest neighbor, genetic algorithm, and Laplace kernel classifier, and also AdaBoost classifier. So coming to the individuals, template matching. Template matching is just a common method. Like it's a method for image processing and pattern recognition. It's a low-level approach which have a predefined templates to search the whole image of the pixel and just I read the word on it. Just let's take an example of a symbol on a stopboard sign. It's clearly written as STOP, so it will be matching the template with the technique, and it's a very low level and straightforward and accurate, not highly accurate. It's accurate. Its accuracy is around the paper which we have referred. Its accuracy is around 89.62 percentage. So coming to the dysentery or the random forest or the uh, dysentery is based upon the random forest. It operates by constructing a multiple decision trees in a lower level, and just take the outputs of each and every tree and then finally decides based upon the majority. It's just like a population of member parliament members voting. And coming to the next algorithm is the k nearest neighbor. K nearest neighbor is the clustering of the images. The nearest sign will be detected when the nearest when you come near to the signboard, then it will get detected, but further boards or anything, multiple boards cannot be detected at once. So coming to the next, it's genetic algorithm. It's a natural based selection process which is mostly used in biological science. This is used by Ayogi et al. And Ekla et al. In the research paper. It is even effective in some phase loss or elimination problem, but cannot guarantee the finding the best solution. As there will be the noisy data, KNN nearest neighbor cannot show the proper and accurate solution. Uh, it is coming to the genetic algorithm. Uh, is sorry, the in the genetic algorithm is popular, but the robustness, adaptability to changes, and flexibility are a remarkable thing in the project which we have seen. Coming to the next, it's a Laplace kernel classifier. Laplace kernel classifier is the uh, classification using probability density function. It just smoothens some parameters which are like pseudo likelihood, and its main theme is based on the cross validation and maximizing the algorithms with some parameters making the outputs as zero. Coming to AdaBoost uh, AdaBoost kernel classifier. mm, I'm sorry, it's uh, the full form of AdaBoost classifier is adaptive boosting classifier. It is a cascade algorithm which is already weak because it is just like a decision tree. It takes the outputs of multiple mini classifiers and give a resulted output. But these classifiers has the separate this classifier has a separate feature of classifying those images, unlike decision tree. So this classifier in the overall task can't perform the uh, in the overall task can perform a better result and high accuracy, but the computational time is very high. Uh, Now coming to the prerequisites.
Coming to the prerequisites, we are using Python 3.6 version and TensorFlow for building the models. Convolution neural model, and Keras we are using it for converting it to the labels. And OpenCV is using for the computer vision work, and Pill is using Pill. We are able to import the images into an array, and tquinter is an GUI user interface library, so which we are using for our graphical user interface. Coming to the methodology, uh, This is a basic methodology for working of an traffic sign recognition, where how it works. Like usually for autonomous vehicles to identify the traffic signs while it moving, the basic thing is first thing is to detect the sign on the roads that is happening to the detection technology while tracking, and whatever the input it's come from, identified sign that is passed to the classification to recognize what kind of sign it is, and then it is that classification will alerts to the output is displayed to the way on to the it was activated to the to the users who are in the driving. So usually in the detection method there will be having two kinds of methods. It is detect based on color based techniques or shape based techniques, and also it can also be used based on hybrid methods. Is like both, either we can use color and shape based techniques both in our detection technologies, which can be useful where sign color sign boards, color signs were not able to identify, then it will go ahead to find with the algorithm of shape based techniques. So in the classification we are using, as discussed earlier, where there were so many algorithms were used in the as told in the last previous slide about ADA boost ladder and neural networks and Laplace kernel, these things. And in our project we are using a CNN convolutional neural network model. Coming to
Coming to methodologies, coming to the methodology, first we need to build the convolutional neural network model, and for that we need to add additional methods for the overfitting issue as we are dealing with a large number of data sets. We use batch normalization, dropout, and data augmentation. Usually, I think we have completed all of them in our course, even though batch normalization is a technique for improving the speed, performance, and stability of a neural network. Uh, these are basically introduced like early 2015s, but batch normalization generally normalizes the input layer by recentering and rescaling them. Uh, so in our image, it will the data when we are getting plotted will recentize and be rescaled based upon the inputs and outputs when moving to the from one layer to the other layer. uh, Data augmentation is a strategy that enables practitioners to significantly increase the diversity of data available from the training models uh, without the actual collecting new data. It can be done without collecting new data. With the basic training data, it can multiply those images, just like if we are having a work under construction board which is triangle in shape. It can be rotated in the form of axis to 60 degrees, 80 degrees, or any degrees, or it can be the mirror image can be just be detected. So coming to the data sets, as I have told you earlier in the methodology how those images are. First one, this is the blur image, which is a speed limit of 70 on the board. So these blur images are the noisy data which disturbs the kernel classification model to not get a full 100% accuracy. And I don't think you guys can see the second thing, which is low light safety sign, which is work under progress. Even we can't detect it properly, but the model can detect it properly. And there is four more other, which are high brightness of the road safety sign image, and also an object blocking the safety sign image. The rest two are it's partially shaded sign, because sometimes when a person is driving, he can't detect detect the sign, or he can't visually see the sign because of the sun rays, as the reflection will be high on it. And this is the light reflected completely, and there won't be, it will be completely dark in color for a visual eye when there is a complete sunlight behind the behind the signboard. So the implementation part.
Coming to the implementation part, we are using as we said, like we are using Tkinter for graphical user interface and using a NumPy for basic calculations, and pandas is we are using for the manipulation of data and those things. For matplotlib pyplot is we are using to show the graphical interface of graphical interface to to us. So CV2 is a kind of a computer vision technology. It's an open CV2, and we are also importing TensorFlow as a tier for building and convolutional neural network, which is very easy to build the deep learning or machine learning algorithms. So, and we are using pill to import image into an array, and also we are importing OS to find, to navigate to the path of the files, path of the files where images are stored. And sklearn model is we are using to split the data into the train and test. And also we are using Keras for labeling the data, converting it to the, the images into the labeled data. So coming to the implementation part of the program, so at first we are retrieving the images and their labels from a location that we are using for OS path, and where it contains, the path contains everything, like folder train where it is having a number of images or classes which having a range from 0 to 42. It will load each and every class of the images into an image folder. So, and then we are also splitting them with the help of uh, sklearn. We are splitting the data into the train and test data. We are using test data as of at 0.2%. Kind of 20% of the data we are taking it for uh, testing the data. So coming to the model, with the help of the help of TensorFlow, we are able to build the convolutional neural network using sequential method, and where in which we are using 2D layers in which it has input and output layers, and then we are using activation as a ReLU function, which with the help of that we are able to assign a weightage to the nodes, and we are using dropout function to reduce but to reduce the burden on, due to the overfitting of large data, we are trying to reduce the pressure on the process. And then we are also using, and after that then we are using Epoch 15 as of now, because we when testing the data, data at Epoch 15, and then after it is standardized with the accuracy. So in our program as of now, we displaying the epochs of 2015. So model fit function we are using to train the data, to train the data, and then we are saving it. So coming to the implementation part, coming to the implementation part of our program, our project, we used two files. One is for graphical user interface, that is GUI.py, and then we used another file with traffic sign.py, that is for use to train and build the model and train the data set, and to find the accuracy of our convolutional neural network. So first I will run with the GUI file, GUI file, so that where it we can able to how that graphical user interface is used to use interface of our application to classify the images using using CNN. In GUI, we are using the trained data set to classify or recognize the images. It is also used TensorFlow in the backend. So this is the graphical user interface. In this program file, we first loaded the trained model. That's something like a traffic classifier.h. We're using a Keras library, and then we build a GUI for uploading the image, and a button is used to classify, which calls the classify method. That method is converting the image into the dimension of shape, something like 130. I can show you that. Well, if I upload it, if I upload the image, and I'm just taking the test data set where I can select any kind of the sign, and then I can open it, and then if I click on the classify image, it was able to classify and recognize the image, sign of the traffic. It is a kind of right of way and at intersection. If you want to identify, coming to the kind of speed limit recognition, if we choose this traffic signal, which is speed limit up to 30 miles per second, so it is able to detect or classify the speed limit at the 30 kilometers per hour. And the same thing, if we choose any different sign with the bad weather condition, under bad condition, this is the bad weather condition image where it is very difficult to recognize, though still it was able to recognize by using color and shape method technologies. So this is because to predict traffic sign, we have to provide the same dimension which we have used when the building the model. Then we predict using predict dot class as images, which returns a number between 0 to 42. It's a kind. This last fourth unit is it varies from 0 to 14 to classify the images, and we use dictionary to get information about the class. So here is the GUI interface code, overall code, where we are classifying buttons to classify and upload, and this is a method to upload the files to classify the images. And coming to the traffic, second part of the training and okay, let me close this. Coming to the second part of implementation of building a convolutional neural network and training the data set, training the data set. Um, It also uses a TensorFlow backend, which used to build a convolutional neural network. In this, we actually build the model as discussed in the previous slides, that we build a model using convolution, using a TensorFlow. And here we are using dropout and batch normalization to overcome the issues of overfitting issues. And we are training data using the model.fit. We are implementing over here, and we are using batch size with the 64, because we tried with the 32 and 64. While working with the batch size 64, we're getting a better results compared to the batch size of 32. So here we are plotting the diagram or graph of accuracy. And okay, and it is taking some time to run. So in the meantime, I can cover it in the code. And here is the code for testing accuracy on test data set. That is, I mean, we are able to, I mean, we are comparing the data with test and validation part, and even we are showing the accuracy of training and validation data set. So yes, it we are using epoch values up to 15 runs. Usually we tried maximum up to 30 epochs also, but after 15 epochs, then it is accuracy rate is standardized. So at maximum we used, we are showing here with the 15 epochs. Um, Coming to the result part, my partner Vashid Dandu will explain about it.
Um, it might take some time for the epochs to run. So in the meanwhile, by seeing these results, which we already have done, which we already have implemented, we get an higher accuracy around 95 percentage, which you can see at the bottom, which is 0.951909197, which is around 95 percentage. So coming to the epochs, for each and every epochs, the value of accuracy is increasing. But when it comes after sixth epoch, you could see epoch, you could see fifth iteration. The value is getting stable from 0.98. It's 98, showing as 98 percentage for the validation accuracy. Where the original accuracy here, this is the training accuracy and this is the validation accuracy. um, so the total accuracy which we got are around stabilized around 95 percentage. uh, so this is the accuracy plot graph in the x-axis where we have the percentage, and at the in the percentage accuracy percentage, and in the y-axis we have the epochs. So from the graph, you could see the two colored lines, which the blue lines indicates the training accuracy and the orange line indicates the validation accuracy. You could see that from the sixth epoch, we could just imagine that it's gonna getting stabilized from almost from the ninth epoch, ninth or tenth epoch. The value of accuracy is getting stabilized. So we are using a large amount of data sets, which are originally the German data sets, which we got from the internet resource. And these data sets are around 30,648 images. Uh, so the final conclusion is, we can use we built a model which is a convolution neural network which helps in classifying the traffic sign with high level accuracy, which is more than 95 percentage for a large number of data sets, as I told, for 30,000, more than 30,400. uh, I think the part of coding is done. The part of results have been completed. Oh, it's on the fourth iteration, fourth epoch. You could see that the value of accuracy for the validation is 0.85, which is 85 percentage. And for the second iteration, it jumps to 93. And for the third iteration, it's getting 96. It's still running. I hope it will be done soon. Until then, we could conclude more of the images from the PPT. As you have seen that for the GUI, we have been using multiple type of images. There are not these are not only the six classes, but there are totally 49 types of classes, around 43 to 49 type of classes. But I don't think the PPT will be enough to define each and every image and test a run on it. So coming to the oh man, it's still in it's on the sixth epoch. So you could see that it's on the sixth epoch. The validation accuracy is 97 percentage, which is increasing. So you could compare this with the plot graph which we have been given in the PPT. Uh, Coming to the plot graph, yeah, it's the start, it's around 70s and 80s, and then increasing from 80s to 90. For the sixth epoch, it's around 90, which is the point will be over here, which is around 93 percentage, 95 percentage, oh, 95 percentage, yeah, around 95 percentage. So this is the project which we are dealing with, and I think we will cut a short amount of video and we'll again keep a snapshot of the final accuracy in the PPT slide. So that's our presentation, and these are the references which we have got. Actually, we have too many more references, but these are amongst the neural networks which are dealing with a large amount of data sets. So the main problem in convolution neural network comes at the time of overfitting. So I we personally felt by filtering these research paper references out, so that they have been completely good at overfitting issues. Accuracy are high. So these are our seven references, and any questions we are ready to answer. We would like to answer any questions. I think the questions as told by Dr. Siming Liu are to be dropped on the discussion box. I and my partner are ready and feeling free. Please to ask some questions about the project if you have any doubts. And thank you.
Thank you, everyone.